eno keke like abadde yasema.
Obisanga naye busanga.
Wabadde we yange obwedda. Ngawone ddala bbiri kale nemanyiyo. Ninga naye tunaayita but 7. Nga mubikira nga nakikuliiridde.
Kati yiyi badde etandise n'oyita.
Ngana subidde mbere ya nusu. Nabadde lubuga ng'enjala ennuma. Nga tubadde naye.
Naye ate yena mukubidde namugamba tuno emmere etandise wano.
Kusambira.
Yabadde mukaaga kituufu.
Yavudde wano n'alyoka ajja.
Nje teyalidde n'oludinga. Namukubidde n'agamba njeeyo ngenda oba yangambye
kulonda. Ng'agenda kulonda ku IVF Lugogo.
Emizannyo gigenda kuddamu. Kale ejjama gyo myangu naye ebyo egy'amasomero.
Simanyi. Nabuuza bagaayi ba USSS tugenda kukola tutya. Ne babaza tulina SOPs gavumenti byega. Netwalaba bonna. Tujja kuba olwo gavumenti ejjagamba mukole eki tugulewo. Tutandikira ku ki? Abaana abalala bakaddiye batandikira wa? Abatazannye bafunye opportunity ki? Munaabazza bazannye.
Abacupa mugenda bbale. Mukayale. Ogweze emyaka gyagamba nakulira mugundi kati abacupa. COVID yabawadde olukusa. Emyaka ng'esatu nga bakikuba. Bala gyagamba emyaka gyange bandinaayinza talenti yange.
Kyokka abantu bakaddiye.
Nasize yaleeta COVID.
Abantu bakaddiye.
Awo
tugenda kuddayo ku kiri buli asoma azannye.
Bano oli ajja kugamba banstopinga nensigala muno mu kirasi. Osebya kati kubamu abaana abayingira first year mu 2019 nasoma 2020 akyali mu first year.
Mukyali awo naye you feel sorry for the freshers. They are still freshers.
Allah yajja COVID. Anyway, ate abantu babiyigiddemu.
Soda kabaati.
Abantu balina ebintu bingi bye bayigiddemu. Ate bya challenge ate COVID namulaba yasinga kwongera bwongo bw'abantu.
Buli atazuukuse mu COVID nobaako kyokola. Besides bino ebyaffe nti oba kati kuba wano okusomesa walina okuba nga ofunye ekintu ekipya kyogenda okutwakaasaganya bw'otakikola. Be ready for disaster. Omusajja w'eyo sente azisibanga ki? Agala kumanya. Ate alina otulagirako bwerere kubanga lwamalaze mu nnyiva g'abagaayi.
Agenda bafunira engeri gye bafunangamu ssente bonna be baasudde. Olaba talumirirwa ggwanga.
Wabula afa kufa ku bagaayi.
Okitegeera naye gaayi gwafaako alina obugagga. Ate bityo babigenda empola abaana bajja tandika okwekyawa mpola mpola. Ate tatalina kukola tageza nabiteekamu obusuulu.
Ngenda kuboola abaana bajja.
Okitegeera tageza nabiteekamu kubanga kano Museveni gye batamanyi buli gyogenda ng'onyigiriza bano abaana obuko bwonna bwe baliko banyigiriziddwa. Okitegeera kinga
abaana babikooye.
Naye gwona nga mwagala kunyigiriza bantu.
Sibitigira.
Ate kuno nanagenda nefuna ebipapula bya minisitule naye saagala genda.
Ebyokusoma ezimu. Naye abantu bagenda okubba ebibuuzo. Genda gamba abaana bange oba nange nkuumeko ku luno tebansibye naye. Oba nkuumeko ku bibuuzo bayinza okusiba. Tebikola makulu. Kale naye kanziyeho kale soni kano. Gwese ani namdala Good evening, everyone. Omusajja ono mudiringa naye mukyagunyu. Agamba simanyi omuzadde yamuweereza ssente mu Desemba, simanyi baweereza ssente, simanyi mu kampu yaffe, simanyi emitwalo mukaaga gaayandi bubi.
University. Inga omanyi nawe olaba.
Good evening, everyone.
Good evening.
Good evening, teacher.
How are you? I sent numbers.
Good evening, teacher.
No one sent me a challenge. I think you passed them. Eh? Did you pass all the numbers? Yeah? I wanted to know which number I should start with. The numbers I sent. There is a number where a particle is fired with an initial velocity of √2. Hope you saw the numbers, most of you. The particle is fired with an initial velocity of √2 to hit a target at a horizontal distance A. So this is the direction of the projectile. It is going to hit a target at a distance A, horizontally. Nkyaliwo paka leta gundi wange. Kasooke muve mu Zoom eno. So the initial velocity of projection is 2GA. The target is at a distance A away. And they are saying from the point of projection and the vertical distance of a half A. So it is a half A up here. Because someone sent to me this number saying he could not get the answer, the two possible angles. Find the two possible angles of projection and the ratio of the times of flight. Yes, please. So the question was saying, find the two possible angles of projection and the ratio of the times of flight along the two paths. Now, to start with, we had the initial velocity. We had x as A. We had y as a half of A. Because we have the initial velocity, we have the horizontal displacement and vertical displacement, the most viable equation we could have taken on is the equation of the trajectory, whereby y is equal to x tan theta, if this is theta, minus gx squared into 1 plus tan squared of theta divided by 2u squared. Remember, this is what we call the equation of the trajectory, the equation which defines the paths and defines by defining the distance moved horizontally, the distance moved vertically, and the initial velocity of projection. So with this, we can substitute. Our y is a half A is equal to our x, which is small a, tan of the angle theta minus GA squared over 2u squared into 1 plus tan squared theta. Okay? So with this reason, when they ask for the two possible angles of projection, this is the best equation to use because it has the ratio of tan in quadratic form. And whenever you have a quadratic equation, we have two possible angles. So we have to solve the tan, which is in terms of tan squared, which is a quadratic in terms of the tan ratio. So with this, when I substitute, I'll have a half A is equal to A tan of theta minus GS squared over 2u under the root. When you square this u, you get 2GA. So for that reason, and up here is still remains 1 plus tan squared theta. I can lose 1A here with this 1A. Then I lose this A with this A and that A. Finally, I will have a half is equal to tan of theta minus, I have also lost this G with this one, minus a quarter into 1 plus tan squared of theta. When I simplify, I'll get 2 is equal to 4 tan of theta minus 1 plus tan squared of theta. When you cross multiply out the 4. Finally, tan squared of theta minus 4 tan of theta plus 3 is equal to 0. When you factorize these two numbers multiplied, you get 3. When added, you get negative 4. That is negative 1 and negative 3. So I'll have tan squared of theta minus 3 tan theta minus tan theta plus 3 is 0. So this would give me tan of theta in 2 brackets, tan theta minus 3 minus 1 into tan theta minus 3 is equal to 0. So finally, tan of theta minus 1 and tan of theta minus 3 is 0. So your trick should be good enough. So this would be tan of theta minus 1 is equal to 0. And this theta 1 gives us 45 degrees. Then tan of theta minus 3 is equal to 0. Then theta will be equal to tan inverse of 3. So the second possible angle is what angle? When you get tan arc, what do you get?
71.5651.
For angles, we can stop to 2 decimal places. How many of you tried out the number and got the answer? Are there some people who got the answers? Eh? Any person who passed this number? I don't remember its order. Okay, that was the first question. Someone has a hand. Edith Naman, that's your question. Before you go to another number.
Teacher, could you help me out with the second step where you cancelled
Here where I divided,
the root of?
Okay.
Yes, because it's
down here there was u squared. Eh? Because u was this one. Eh?
Yes.
When I square u, I'll get root of 2ga, but the whole of this one is what? Squared. When you square that, you get 2ga.
Oh.
Okay?
Okay. Thank you.
Welcome.
Yes.
Oh, then they say the part 2 are saying what? The ratio of the times of flight along the 2 paths. Now, first of all, if they say there are 2 possible angles, this is what it means. One angle is 71.56. The other angle is 45. So this one will be 45. Then this one will be 71.56. So this one will have a path like this one. Then this one will have a path like this one. But with the same speed. Eh? Now they are saying, find the time, they said what? The ratio of the times of flight. So we need to find the time of flight for the first one. Remember, for the first one, time of flight is what? Time of flight is 2u. Okay, it is u squared, sine of 2 alpha, over what? Over g. Okay? Now, I can use trigonometry. I need to extract out this triangle. Because one of the angles, let me assume this is theta. If the angle is theta, we have seen tan theta tan of theta was, tan of 45 is 1. So 45 comes from 1 and 1, and here we have root 2. Why? Because tan is opposite over what? Adjacent. So to get theta is that, it means tan theta is 45. So when I substitute for T1, I will have root of 2GA, but when this root is squared, times sine of 45 times 2. But sine of 45 times 2 is the same as sine of 90. This will give us 2GA times 1 over G. I divide by 2, and then I'll get the first time of flight as 2A. Then the second time of flight, oh wait, no, I've used an equation for, Murunji, you have a concern. Is that the same that you've seen? I've used an equation for the range instead of the equation for time of flight, sorry. Yes, please.
Teacher.
Yeah.
Teacher, my concern is on that diagram. One of the angles is 45 and the other one is 71.5. So I expected the one with 71.5 to, the particle should land nearer than the one which was thrown at an angle of 45 degrees.
Yeah, you expected it to be like this. Something like that.
Yes, teacher.
There's one thing you should know. When these trajectories are happening, if you've seen people who throw javelin, that spear they use in athletics, the higher the spear goes, the farther it travels. And then the lower the spear goes, the shorter it travels. The same is applied to the angle. What you think is not what happens. If the velocity is the same, it can't be before. There is no way. Anyway, we are going to see which one has the greatest time. Then it will confirm to you that with the bigger angle or with a smaller angle, where does it land? Because to land faster, it means the time is what? It means when it lands in a closer range, it means the time it has taken is short. If it lands in a greater range, it means the time it has taken is less. It will be longer. So time of flight is 2u sine of theta over g. And it is the reason why I drew this triangle, but I don't know why I wrote the range instead. So T1 will be got from twice root of 2GA times 1 over root 2 divided by G. This will give me 2 times root 2 times root of GA times 1 over root 2 over G. 1 over root 2 comes from sine of theta, which is 1 over root 2. So this root 2 can die with this one. So I'll remain with 2 root of A over root of G. Yes, please.
What on the way do the triangle?
Okay. Now the triangle, look here. The triangle, I've drawn it like this. Tan of theta towards tan of 45 is equal to 1, not so? So it means theta is here. So tan is opposite over adjacent. Square root using Pythagoras theorem, we shall have root of 2. Right there. So to get sine of the angle is the opposite over the hypotenuse, which opposite is 1, then the hypotenuse is root 2. Then the adjacent, if I want to get the cos, I can get it from 1 out of root 2. So that's how I made that substitution. Now on this number, how I've divided root 2, root of G out of G, this is the same as writing 1 out of G times G power negative a half. So that's how the G became under a root down to bring about this part. Okay, so the first ratio, the first time is T1, I've given it that. Can we now deduce the second one? For the second angle T2, T2 is given by 2u sine of theta 2 divided by G. And this time round, we had tan of theta minus 3 is equal to 0. So if tan of theta minus 3 was equal to 0, it means tan theta was 3. Now, when you come to the right angle triangle, it is opposite over adjacent, so the adjacent is 1, the opposite is 3. When you square this and square that and you add them, you realize root of 10. Therefore, sine theta in this sense is equal to 3 out of root of 10. So to get T2, one can now substitute 2 times root of 2GA times 3 over root of 10 divided by the G. So with this sense, I can split the root and I confirm twice of root 2 times root of G A times a 3. Remember your surds of primary here, root of 5 times root of 2 to split the root of 10. Then all this is divided by a G so that I can lose my root 2 with this root 2 by division. Remember, this G also can be lost by coming down. Yeah? So this one becomes power a half. So when it comes down, this is what is going to happen. We shall have 6 root of A divided by 5 root of G. This is our T2. Because the question wants the ratio, so you need to confirm T1 divided by T2. And this will take us to twice root of A over G divided by 6 over 5 root of A over G. Then you divide root of A over A over G off, and the answer becomes 10 to 5. Is it 10 to 5? How come I have a different answer? This is 5 goes up by 3, by 2 once, by 2 here, 3. So the answer becomes 5 to 3. I think with that algebra, that should be the answer. Confirm if one of my algebra is having a challenge.
Excuse me, teacher. Excuse me, teacher.
Yes, please.
So, teacher, which of the two gives a longer time?
Which of the two gives a longer time? According to this one, it is showing that T1, the ratio of T1 is bigger than T2. T1 was which one? T1 was 45, eh?
Yes.
Yeah. Okay, now the explanation for that is this. Do you remember that we proved that 45 gives the biggest maximum possible range?
Yes, teacher.
Yeah, now that's when Murungi's explanation comes in. Okay, but it would have been possible, it wouldn't have been possible to have 71 being shorter, but because the maximum range cannot exceed 45 degrees, then the 45 should have been longer. So the diagram would have looked now like this. You would have sketched with this as 71.56 landing here. Then you sketch with 45 in this sense, and the 45 degrees would go and land here. So this would take T1, this would take T2. So this diagram was not depicting what the result has given us. Okay, the other question.
So teacher, excuse me, sir.
Yes, please.
Teacher, so on these different angles of 71.5 and 45 degrees, so we just assume where the object
So
is
we
going to land.
we had to bring into account the condition of maximum range. That 45 gives us the maximum possible range. Any other angle does not give us so. So because we had 45 into play, then 45 would have been a bigger what? A big, it would have taken a longer time than the 71.
Oh, so it's still the same principle of javelin.
Yeah. So even for javelin, if one wants to throw the highest throw compared to other athletes, you make sure you throw that javelin at an angle of 45 degrees. Then you increase the energy in your arm so that the speed with which it takes off is high enough. Then you can throw it to a very good distance.
Excuse me, teacher.
Yes, please.
Excuse me, teacher. So, not a question, but teacher, like my WhatsApp is so like said contacting, my messages never go, and I didn't see the work.
You didn't see the work. You inbox me on my WhatsApp.
Yes. I've said it's slow, it can't, the messages never go.
How about your email?
I have an email.
You don't have an email? Okay, you delete most of the
I
messages.
have an email.
Try to empty most of the messages on WhatsApp. And empty some of your folders, your image folders.
Okay, teacher.
So what's the next number that challenged you guys? Next challenging number. Hey, wow. Sure, baby, sing. I want to know which number I should go for. Should I go for this one of a projectile fired at a point on a cliff? I think it was number what? Number 4? So it says a projectile is fired from a cliff at a point of 60 meters. So it is 60 meters. The cliff is 60 meters, and we are firing a projectile from here, and this projectile is going to go and then come back and land somewhere here. So they are saying from a point 60 meters vertically above, it is fired vertically above it. The velocity of projection is that due to, or is that due to the falling freely? Is that due to falling freely?
Excuse me, teacher.
Yes, please.
I beg your pardon with the question.
The question is, the projectile is fired from a point on a cliff, 60 meters, horizontally from a point Have you seen that number?
Yes, teacher, I've seen it. Thank you.
Then when they say it has a, the velocity of projection is that due to a falling freely under gravity through 30 meters from rest. So a falling freely under gravity falls like this. Remember the equations of motion? When something is falling freely, they're saying it's falling freely through 30. So that means the velocity is this one. The initial velocity is 0 plus 2 times 9.8 times 30. When you get the square root, what velocity do we get? This is 98 times 6, which is 540, plus 48, that is 588, which is square root of, if you leave this as 60, it is 60g under the square root. So if that is the velocity, so it's the velocity with which the particle is projected. Then they say that show that the possible directions of projection are at right angles and find the corresponding times of the flight. So still they're asking you to show or to find the possible angles of projection. So the particle is going to leave and go and fall down. But as it goes, they have said it's fired from a cliff of 60 meters high and horizontally from a point of 60 meters vertically above it. That's where it falls. So when it is at that point, sorry. So it is at that point, it is at a point where it is 60. Let me assume the 60 is here. Someone has a concern. Which page of the book?
Teacher, they say it's horizontally, it's fired horizontally. Excuse me, teacher.
No, they say
teacher.
From a point on a cliff.
On a cliff, horizontally.
Listen, it is fired from a point on a cliff. Yeah? 60 meters horizontally from the point of projection. The 60 meters from the point of projection is here. So this distance is 60 meters. And also the cliff is 60 meters. So 60 meters above it, so above the level of projection, above the horizontal, it is 60. And also at this point, it is where we're having 60. So they want us to show that the possible directions of projection are at right angles. So using our general equation of the trajectory, y is equal to x tan of theta minus gx squared into 1 plus tan squared theta over 2u squared. The particle is going below the point of projection. And whenever the particle goes below the point of projection, the first equation, which equation? This one. This equation, they said, the question said, the velocity of projection is that due to a freely under gravity, is that due to a falling freely under gravity through 30 meters? Is that of a body, anything that is falling freely through a distance of 30 meters? So you get the velocity of that body that is falling through a distance of 30 meters freely under gravity. When it is falling freely, the initial velocity is 0. It is covering a distance of 30 meters. So when you substitute, you realize that as the V. Now, when I substitute, before I substitute, the particle is going below the point of projection. If this is where we are projecting it from, and the particle leaves and comes down, it is going to cover a negative displacement. Because we said when it goes and comes back to this level, which is close to the level, or which is the same as the level of projection, the height displaced is what? Is 0. So in that sense, this will be a negative y is equal to x tan of theta minus gx squared over 2u squared into 1 plus tan squared theta. So can we now substitute? We shall have negative 60 is equal to 60 tan of theta minus g times 60 squared over 2 times 60g into 1 plus tan squared of theta. The 2u squared is the same as, this is our u. When you square it, you get 60g. That's why I've realized this part. So the whole of this one, I'll lose this g with this. I'll lose 160 with this one. Then the 60 which has remained can be divided by this 2 to give us 30. So with that sense, I can be in position to say negative 60 is equal to 60 tan of theta minus 30 into 1 plus tan squared of theta. When I divide everything by 30, I'll get negative 2 is equal to 2 tan of theta minus 1 plus tan squared of theta. Finally, when I design a quadratic in tan, I'll get tan squared theta minus 2 tan of theta minus 1 is 0. Two numbers multiplied, you get negative 1. When you added, you get negative 2. Those numbers are negative 1. No, sorry, those numbers are what? Two numbers multiplied, you get negative 1. When added, you get negative 2. I think they are not there. So we can use bulldozer and substitute everything in the formula, which will give us 2 plus or minus under root of 4 plus 4 times 1 over 2 times 1. What are the answers you get for tan? Tan theta 1 is, this is 8 root of 8. What is the first one? You can press the calculator straight away when you write the quadratic equation. Please press the calc.
2.414.
You get
2.414.
2.4142. The second one? Which exercise?
Negative 0.4142.
Negative 0.4142. Can we get the corresponding angles theta 1?
$67.4999.
67.5. The second one.
Negative 22.45. Sorry, 4993.
Negative
22.4993.
0.5. Eh? Now we can't take a negative because we saw we projected the vertical particle upwards. Okay. So what we can do, we can investigate using trigonometry. Using all students take cocaine. Tan is negative. Negative 22 is here, not so? Yeah? This is where negative 22.5 can be. So to get the positive angle, you read it from this side going this way. Yeah, from trig. Eh? So if this angle is 22.5, this is also 22.5. But we want this positive one, which will be 180 minus 22.5. What answer do we get? We get 150 what? So we take the
10.5.
positive. 157.5. 157.5. So you always look, in case you get a negative angle, always look out for its corresponding positive. Eh? It's what you consider. So it means the other possible angle would be this side. Okay, there is that number 5 there also I should try, which was saying express it in vector form. Eh? I don't know that people tried it out. However much we have not yet covered vectors, but you land on vectors, which are in form of projectiles, which are in form of vectors. It is healthy to try them out. So let me do that, and also go for should I start proofs today? Oh, there is a number which I sent, which was a tennis player clearing a ball. Did I send it? That number was in understanding. Let me do that number. Then I also sent you Messi. Did you guys do the Messi number? Those are all very interesting numbers. We still have one.
First, we didn't even get a single.
You didn't even get what?
A single number. Like we don't have that work that you're reading, that you're doing.
You don't have WhatsApp.
We've checked WhatsApp. It's not there. We checked in the Google class of math. The work is not there.
Sure. Let me.
Yeah.
Yes, teacher, for mine, I didn't see the exercise.
Yes, teacher, we didn't get anything.
Yeah, you hear them.
So maybe they are not in our WhatsApp group for math.
WhatsApp group is that?
All of us answer on WhatsApp, so we just get the work from Google Class.
Yes, I'm in
Sent
Google
it in the
Class,
solve.
but no,
Just sent it in the solve all math WhatsApp group.
You mean there is a math WhatsApp group?
Ah, you mean you're not in the know?
Yeah.
But every lesson I write down my number for people to WhatsApp me so that I add them to the WhatsApp group. Every lesson.
So we thought you're speaking of the math, the general WhatsApp group.
Every lesson I speak of, come on. You WhatsApp me now. Google Class, I promise I'm going to upload them on my Google Class. Because I sent them to Mr. Brand to upload them on Google Class. I think he didn't. And the problem, my WhatsApp is cannot access the laptop anymore. I wanted
By the
to.
way, teacher,
Hmm.
like the question was, show that the possible directions of projection are at right angles and find the corresponding time of light.
If they are right angles, then subtract and see whether the angle between them is 90. I think it's true. Isn't it? Right? It's 90, right? So if it's 90, we can.
Yes.
Okay. Then the times we can have T1. They said find what?
Corresponding times of light.
Corresponding times of flight. So their times of flight, we are covering a distance of 60 horizontally. So we shall have, you can either use x over u cos theta 1, which is 60 divided by the initial speed, which is what? Root of 60 times 9.8 cos of 67.5. Then you get the answer. Then you try out the second one and do the same.
Sir,
Yes, please.
I have WhatsApped you.
Okay. Others also access my Google Class, my personal. It's Wama Hamza. But I haven't seen your WhatsApp.
Google Class.
Yeah, I'm also going to put on my Google Class. I told Mr. Brian to upload on the Gen one. I don't know whether he failed to.
Can you type your name in Google Class?
Yeah. That's my name. Can you access my Google Class now? Yeah?
But I don't know how to get there.
Yeah. Okay, let's first do these numbers. Okay, let me write this one down. This one is short.
I'm in Google Class.
A particle. This one, let me just write it down. Particle is projected from a point with a speed of 20 meters per second. So I'll be uploading on my Google Class at an angle of 60 degrees to the horizontal. Express in vector form. Express in vector form its velocity, v, and and its displacement. And its displacement r from O at any time t. So have it down. Let me bring another book here. What do you want? I'm still very busy. What do you want? What is it? About what? Yeah, let me see. You will see me. You see me at 10:30, 9:30. Discussion is being around 9:45 of 10. I'm in a Zoom class right now. Guys, are you there? You respond so that my student here gets to know that you're in class.
Yeah, we are there.
Class, we are learning.
Excuse me, teacher. 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 Excuse me, teacher.
Sir, you're muted.
I wasn't muted. You mean you can't hear me still?
Teacher, I can hear you now.
You can. You mean before you were not?
Yes.
Okay. I said
Teacher?
the yes, please.
Like I was asking you, I got a negative on the second time.
Even when you use negative 22.5, you press cos negative 22.5. What do you
I've not
get?
yet chosen it.
You use it.
You get positive.
You get a positive because cos of positive, a negative theta less than 90 is positive. So that's what you use rather than the 157.
Okay, thank you, teacher.
Welcome. Right. So if someone wants to write it in terms of I and j, then V shall be 10I plus 10 root 3 minus GT J. And that would be the answer. They never gave you the time. So they said express it in form of V and its displacement. Now for displacement, we need to know that X is equal to UT cos theta. That one we know now. So x is going to be 20 t cos of 60. But cos of 60 is a half. So this will give us 10t. Then for y, it is equal to ut sine of theta minus gt squared over 2. This is the same as what? Y is equal to 20 times t times sine of 60 minus gt squared over 2, which will give us 10 root 3 of t minus gt squared over 2. So if I want to express r, the displacement, in a vector form, it is the horizontal component xi plus the vertical component yj. The vertical component goes in the I direction. So sometimes write it in column form as x what? Y. So r in general will be 10t I plus 10 root 3 t minus gt squared over 2. This is j. So if someone wants to express this in this other form, we can have r is equal to 10 t in column form of 10 root 3 t minus gt squared, what is over 2. Then you can express this in column form, meters. So with that, you would have expressed the position or the displacement in vector form, but without forgetting the vector notations. When you miss the vector notations, you get 0 because of poor presentation. The vector notation is that wave you see below. This means vector r. When you just write r, it means it's any other alphabetical letter. Yeah. When I write small I, this is vector I, direction vector I. Okay. So when they express them in vector form, you have to express them in terms of I and j. But later on, we shall see that we have I, j, and k. So that's what the expression wanted. So you can download that number unless someone has a question. Let me write down one other number for our colleagues who don't have the numbers. There is a book I also sent, which is Humphrey. It's also on my Google class. Also, most of these other books are there. We need to visit some Humphrey numbers. The next, I told you we have the other 2 lessons. So the next lesson should be for proofs mainly. We shall do a lot of proofs on the next lesson.
Yeah, wait.
Next lesson. The next lesson is going to be on days, which day is man. Should we have another lesson next tomorrow? Yeah, but I'm running tired. Next lesson will be Friday night. God willing, after the lesson in the day. Obi, sometimes I want. Nziwanomvaawo sawa mukaaga. One child in class, get them class. Get them class from senior 6 hours. Yeah. Kiri mukasonda wali kugundi ku calendar. Tasobola kumala budde. Yeah, let me end with this number for Messi. It's quite long. No, yeah, we check our card. The empties. Zikora, I will bring a bottle. A small. When is the next lesson for what? The next lesson for mechanics is going to be Friday. And likewise, we shall have another night lesson, I think. Salam. Okay, let me write the number down as people are finalizing that right up. Messi kicks a ball. Yes, someone has a question. Teacher, your name on the Google Class, Rubama Hamza. I don't know if people, some of you. Who is coming now? This number is the longest number. So it reads, Messi kicks a ball at a speed of 8 meters per second at an angle of 30 degrees with the ground to a striker. The ball strikes the ground at a point which was at the same level with the point of projection. After impact, teacher, which team do you support? Why are you asking me? After impact with the ground, the ball bounces and the horizontal component of velocity remains the same, while the vertical component of velocity is reversed and halved. If Salah, running after the ball, kicks it again when it is at a distance of 1 meter horizontally from the point where it first bounced, find the 1 distance between the point of projection and where the ball first lands. Those of you who began these lessons with us, I told you we have what we call the critical thinking number. It is always a number in paper 2. And that number can appear in mechanics or it can appear in stat. So we call it a CTN. And they are saying G is 10 meters per second squared. So for Roman 2, time interval between the ball landing and Salah kicking it again. Then 3, find the height. Find the height at which Salah kicks the ball. Okay, there is our number. This is our last number tonight. Hope our friends who are complaining that they didn't have numbers are now settled. So if I'm to illustrate to you how this model looks like, we are looking at Messi projecting the ball, giving it a kick with an initial velocity of 8 meters per second. So he was initially 8 meters per second. So this ball made a trajectory and came and landed here. Then the ball made a second trajectory until when Sarah found it. And that's where the mechanics is. So it's a very interesting number to look at. So it was the CTN. So this is 30 degrees. We don't know this range. The first question says, find the distance between the point of, yes, please. Yeah?
What do you mean by CTN?
CTN is a critical thinking number. It's found in paper 2, either in mechanics or in statistics. So you have to be very sensitive when choosing those numbers. Okay, can we go for the number now? The first part says distance between the point of projection and where the ball first lands. So in actual sense, they're asking us for the range. Of course, one can use X, or one can go straight away and say range is equal to U squared sine 2 alpha over G, which will give us 8 squared sine of 60 divided by 10. This will give us 64 root of 3 divided by 20. By 2, 32. By 2, 10. By 2, 5. By 2, 16. The answer will be 16 root of 3 over 5 meters. But of course, that's the best answer, but you can get decimals and then put it to 4 decimal places. When you compute in decimals, what answer do you get? What answer do you get when you compute that?
5.5426.
The second question. Interval between the ball landing and Sarah kicking it again. Where does Sarah kick it again? They have said, after impact with the ground, the ball bounces and the horizontal component of velocity remains the same. Remember, the horizontal component of velocity is always u cos theta. So even here, it remains the same as u cos theta. Then they have said the vertical component is reversed. Reverse it. Vy. And then it is halved. So the new vertical velocity will be a half of Vy you had before. So you need to get the resultant so that you find the new angle. Let me assume this angle was theta. This one will be alpha. So I'll need to first find.
Did I beg your pardon with the explanation?
Okay, let me extract it out here. After landing like this, has it landed? It comes with a final velocity Vy. And they have told you the final velocity Vy has been reversed. So we have a negative Vy because the positive was going forward. Then the horizontal component of velocity remains the same, which is Ux, which never changes, is always u cos theta. So you have to get the resultant of these two, which predicts the direction with which the particle rises again, so that Sarah can kick the ball again. Is that better?
Yes, teacher.
Okay. So if that's better, we need to first find Vy. Vy is got from u sine alpha now, no, theta minus gt. But we didn't have the time. So the time is time of flight to land here at point B. Left point A. So the time of flight, get it. Time of flight is 2u sine of theta over g, which is twice times 8 sine of 30 divided by 10. This will give me 16 divided by 2, 8. 8 divided by 10, you get 0.8 seconds, is it? Yeah, 0.8 seconds. So when I substitute it up here, I'll get Vy is equal to 8 times sine of 30 minus 10 times 0.8. You see that Vy is equal to 4 minus 8, and Vy is negative 4 meters per second. But this negative 4 is the velocity with which it was landing down. Remember, when the particle is coming back down, velocity is negative. Now we reverse that negative 4 to become a positivity. When the negative 4 has become a positivity, they have told you half it. So it will become negative of 4, half it, then it becomes a positive 2. Now here we have a positive 2, while here we shall have 8 cos of 30. So ideally, I extract out my new illustration. This is 8 root 3 divided by 2. This is 2. Get the resultant. Pythagoras theorem. Here once, here 4. 16 times 3 is 48. Plus 4, root of 52. So we have this one here as root of 52. On the new angle, which is alpha. Now they are saying the time interval between the ball landing and Sarah kicking it again. So they want the time from here. Sarah is kicking it after 1 meter horizontally traveling. So X.
So what have you extracted out?
I've extracted out this vertical component with this horizontal component. The horizontal component was 8 cos 30. The vertical component was negative 4 on landing down. But then they said the vertical component, the horizontal component remains the same. You see that statement? While the vertical component is reversed and halved. So I have reversed the negative 4 to become a positive 4. But halving it gives you positive 2. Then you get the resultant using Pythagoras theorem. Are you better now?
Yes, teacher.
More action. We wanted to find what? Time interval. I said we can use the x. So x is equal to ut cos of alpha. But now the new u is this velocity root of 52. So I'll have x, which is now what? X is 1 meter. So 1 is equal to root of 52 times the time we are looking for times cos of alpha. From here, cos of alpha is 4 root 3 divided by root 52. So I'll get 1 is equal to root of 52 times 4 root 3 divided by root 52 times time. The time can vanish with this, and my time is actually 1/4 root of 3 seconds. When you expand, when you compute that, what answer do you get?
With the speech president, we are now demonstrating
Guys, answer. 1 divided by 4 root 3. It's the same as root 3 over 12. Eh?
.1443 seconds.
0 point. So that's the time interval between the ball landing the ground and Salah kicking the ball again. Then the Roman 3 wants to find the height at which Salah kicks the ball. This is height h. So height h, forget about the first trajectory. We are on the second trajectory now. We are kicking the ball at this height h when it is 1 meter away, and it is being projected at what angle? Alpha. At what initial speed? Root 52. So we have the initial speed, we have the angle of projection, we have the distance x. We can use equation of the trajectory. So when you substitute height h is y, x is 1 meter, you get the turn from here. The turn is 2 divided by 4 root 3 minus 10 times 1 squared divided by 2 times 52 into 1 plus tan squared theta, which is going to be 2 squared over 4 root 3. The whole of this is squared. So when you compute this, we shall have h is equal to, this is a half of root 3 minus 10 over 104 into 1 plus 4 over 48. Press the calculator and get me the height.
Teacher?
Yes, please.
Teacher, I'm getting 0.1845.
0.1845 meters. Okay, any questions? This was a very critical number, thinking number. You know, you wouldn't just have rushed it through. Any questions? Okay. What were you saying?
Teacher, no questions.
No questions. So people should, do people take screenshots? I stop my, I need to stop the running of my what? I'm going to send more numbers from Humphrey.
Teacher?
Mm.
I try typing writing Hamza in that place where you join a Google class, and it was instead asking for a code, class code.
Sure. That it is coded.
Yes.
I don't think it's coded. Let me check. It is not coded. It's open. Try again. I'm
okay.
I'm right here.
Okay.
Okay. Let's stop here. We shall start from there next time, Friday. In case of any challenging numbers, you can send them via my WhatsApp.